point slope form. Point slope form, again, like I just said, it's another format of being able to write a linear equation. It is written in the following format, where you have y, which is your variable, minus y1, which is a y coordinate, is equal to m, which is your slope, times x minus x1, where x1 is the coordinate, an actual physical coordinate. So what I'm going to go ahead and do, I'm going to highlight that m in green, because I've always done that as my slope. M is going to represent that slope that we have for our equations. And then you've got the point x1 and y1 are going to represent the coordinates to a given point, where x1 is obviously the x coordinate to a point, and then the y1 is the y coordinate to the point. Now, very carefully, you need to make sure that you are aware of your negative coordinates. That is where the most mistakes tend to be made, is when we are given negative coordinates, because people tend to accidentally drop their negatives. So just be mindful. Be mindful of points that have negative values included in them. Just make sure you're aware of that. So let's go ahead. We're going to first start off with an example where we're given a point and we're given the slope. We're going to place it into our formula, our point slope formula, and simplify it. And then we're going to go ahead and convert that into slope intercept form. Okay, so the first thing that I need to do is identify my components. I have three things that are going to get replaced. The letter M is going to get replaced, X1 is going to get replaced, and the Y1 is going to be replaced. So I want to go ahead and identify what those values are. My M again is going to be my value for my slope, so that's going to be 3/2. My x1 is going to be the x coordinate, which is equal to 2. And my y1 is going to be that y coordinate, which is equal to 6. So these are the values that I'm going to substitute into my equation. So again, like I said before, the equation is just equal to y minus y1 equals m times the quantity of x minus x1. So everywhere where I see one of those variables, I'm going to replace it with the value that I have here. So I have y minus, and instead of y1, I'm going to replace it with a 6. So it's y minus 6. That's going to be equal to, instead of m, I'm going to replace it with 3/2. And then in parentheses, I'm going to have x minus, and then instead of the x1, I'm going to replace it with a 2. So this is the equation written in point slope form. Now we want to take that equation and we're going to go ahead and rewrite it or convert it into slope intercept form so that y is completely isolated, y is by itself. So I'm going to take that equation, that y minus 6 is equal to 3/2 times x minus 2. And remember, when we're solving, the very first thing that we should always do when solving, if you look at the backboard, the solving equations backboard, step 1, can somebody back there read to me, what does step 1 always say that you need to check to do? Distribute. You should always check and see if you can distribute. So the first thing that we want to do is go ahead and distribute that slope value to each component that's inside the parentheses. That's the first thing that we want to do. So we're going to do 3/2 times x. We're also going to do 3/2 times that -2 or that -2. Okay, So y minus 6 is going to stay as is. 3 over 2 times x is just going to give me 3 over 2x. And then 3 over 2 times a negative 2 is going to come out to a negative 3. So we've just distributed those values. Okay, there's only one other thing that we now need to do in order to get y isolated. What do we need to do to get y isolated? Bonnie, what are we going to do here in order to get y isolated? Huh? We want to get y isolated. That means by itself. Is y by itself right now? What's attached to it? A minus 6. So what do we do to get y by itself? Is that an inverse operation to minus plus 6? Guys, you got to remember those inverses. This is stuff that you've been doing all year. The inverse to a subtraction problem is an addition problem. You need to add 6. Am I able to add 6 to 3 halves x? No, because they're not like terms. But can I add 6 to that minus 3? Yes. Okay, addition and subtraction can only happen one time. Multiplication and division happens to everything. If you're multiplying, you multiply to everything. If you divide to everything. Addition and subtraction can only happen one time, and they can only happen with like terms. Okay? These are going to wind up getting canceled out so that y is now isolated. So we'll have y is equal to 3 over 2x. And what is negative 3 plus 6 going to come out to? 3, positive 3. So we get 3 over 2x plus 3. That'll be our final answer. Okay, so let me go over it just one more time. You're going to take the components that you have up here. You're going to take your slope and your x and y coordinates. You're going to substitute it into that formula. You're going to replace your y1 with whatever your y coordinate is. Replace your m with whatever your slope is. Replace your x with whatever your x coordinate is. Then to convert, you're first going to distribute your slope to each term inside of the parentheses, and then you're going to add or subtract whatever constant is paired with the y to the other side. And then that's it. So you distribute, which is multiplication to each of these, and then add or subtract to the other side. That's it. Okay? Let's take a look at example 2. I'm going to do example 2 with you, and then you'll do example 3, and I believe you'll just do example 3 on your own. All right, let's take a look at problem number 2. Problem number 2, my x and y coordinates are negative 2, that's my x1, positive 3, that's my y1, and then slope, that's my m. So I'm going to go ahead and replace those. I'm going to put m is equal to 4, x1 is equal to negative 2, y1 is equal to a positive 3. When I substitute, I'm going to do y minus my y1 coordinate. So I'm going to do y minus 3 is equal to my slope, which is 4, times x minus my x1 coordinate, which is a negative 2. Now notice, anytime that we have a minus and a negative, what is that really saying? A positive, right? Those double negatives really indicate a positive. So you're actually not subtracting a negative, you're actually adding a positive value. So let's go ahead and rewrite that as y minus 3 is equal to 4 times x plus 2. Okay, you can actually simplify. double negatives equals a positive. Double negatives will equal a positive. So you want to make sure that you're aware of that. All right, now we're going to go ahead and do the conversion. We're going to convert it into slope-intercept form. So we have y minus 3 is equal to 4 times the quantity of x plus 2. The first thing that we need to make sure we do is distribute. That means we're going to take the 4 that is on the outside and we're going to multiply it by x. What is 4 times x? 4x. And then we're going to do the 4 and multiply it by a positive 2. What's 4 times 2? 8. Positive 8. So we now have y minus 3 is equal to 4x plus 8. Aiden, what do we do now? Which is what? So we're going to, what is the operation? Add. We're going to add 3. We're going to add 3. Remember, inverses are operations. Don't just tell me you're going to do the inverse of something. Tell me what the actual inverse is. Okay? If this was what it used to be with milestones. Milestones used to have you indicate or type out your steps, not just show your work, but literally type out a written explanation of how you would have to solve something, where you would say the first step is to distribute my 4 to my x and to my 2 by multiplying. Okay, literally saying exactly what a teacher would tell you. If I come around and I'm teaching you, and the first thing I ever tell you about inverses is just to say inverse, and you had never heard of the word before, would you know that an inverse is an opposite operation, or what the opposite operation would be? Okay, you have to explain it as if you're trying to tell it to a 5-year-old. It's silly, but that's what you have to do. You have to try to explain it as if you're explaining it to a 5-year-old. Break it down step by step. Okay? All right, when we do that, those constants are going to go ahead and get canceled out because they are 0 pairs. 0 pairs are direct opposites of each other. So we're left with the y all isolated now. 4x is unaffected, but that positive 8 is now being increased by a positive 3 to give us a positive 11. So our final answer, 4x plus 11. Y is equal to 4x plus 11. I want you guys to go ahead and do problem 3 on your own. All right, let's go ahead and go over this. What's the slope, guys? -1/2. What's the x1 coordinate? -1. What's the y1 coordinate? 2. Okay, so when we substitute this in, it's going to say y minus 2 is equal to our slope of -1/2 times the quantity of x minus -1. What should I do? Good. Hey, but that's a good catch. David started to say, oh, well, let's distribute. But then when he got to the O, he says we're going to multiply -1/2 times x, and then we're going to multiply -1/2 times, oh, wait, no, hold on. So he realized halfway through, oh, I need to go ahead and simplify that first. Remember, you've got those double negatives. If you have those double negatives, you got to convert that into a positive first, because you don't want to do a -1/2 times a -1. Like, you wouldn't be able to do that. So you want to make sure you're simplifying that portion first before you continue. So that's going to become y minus 2 is equal to -1/2 times x plus 1. Okay, from there, then we can start to do the conversion, which is now to go ahead and distribute, right? We want to distribute after we've double checked to make sure, oops, that we don't have double negatives. So we're going to go ahead and do our distribution. We're going to take that negative 1/2 and multiply it to the x, and negative 1/2 and multiply it to the positive 1. So we are left with y minus 2 is equal to a negative 1/2 x minus 1/2, right? Negative half times a positive 1 is just a negative half. All right, our next step, Devin, what are we going to do next? Very good. Add 2 to both sides. It's okay, guys, if it takes you a little bit of time to figure that out where we are. It's okay, right? Don't panic. That's the last thing you want to do. We're going to add 2 to both sides. Those 2's are going to cancel out because they are 0 pairs, so they are direct opposites. And we're going to get y is equal to negative 1/2 x. A negative half plus a positive 2 is going to wind up coming out to a positive 1.5 or a positive 3/2. When in doubt, leave them in fraction form. Just put it all in fraction form. If you happen to notice that an answer choice is not in fraction form, then you can go ahead and do your conversion to a decimal, okay? But when in doubt, always just go ahead with leaving it in fraction form to begin with. Any questions about dealing with a point and a slope given to you? All right, now sometimes slope isn't going to be directly given to you. Sometimes they might just give you 2 points instead. But if we have 2 points, can we find the slope? If we're given 2 points, can we actually find slope? Yeah. If you are given 2 points, you can find slope by doing the slope formula. As a reminder, the slope formula is y2 minus y1 over x2 minus x1. That is your slope formula. M will be equivalent to subtraction of your y's over the subtraction of your x's. It does not matter which points that you put first and which point you put second, as long as you are being consistent. If I put 1 minus 9, I have to put 8 minus negative 2. I can't do 1 minus 9 and then negative 2 minus 8. I have to be consistent with the order that I'm going in, okay? So the first thing that I want to do here is go ahead and identify the slope. Again, like I said, it doesn't matter what I do as long as I'm being consistent. So I'm going to go ahead and do 9 minus 1 on the top, which means I'm going to have to do negative 2 minus 8 on the bottom. Subtraction of my y's over the subtraction of my x's. When I do 9 minus 1, that gives me an 8. Negative 2 minus 8 gives me a negative 10. And then I just need to simplify. 8 over negative 10, I can bring the negative out in front, and then 8 over 10 simplifies to 4/5. So there's my slope. My slope is 4/5, negative 4/5. Now, when I'm putting it into point slope form, it doesn't matter which point I choose for point slope. It will come out the same. It will come out identical in the end when you go ahead and simplify it. So let me go ahead and show you. I'm going to go ahead and start with the first point. I'm going to do y minus 1 is equal to negative 4/5 times the quantity of x minus 8. Oops, wrong color. X minus the 8. I don't have double negatives, but I can go ahead and distribute. So that would become negative 4/5 x plus 32 over 5. Because negative times negative is a positive, and 4/5 times 8 is 32 over 5. I still have that y minus 1 on the other side, though. So the last thing I'm going to do is add 1 to both sides. By doing so, I'm going to wind up getting y is equal to negative 4/5 x plus, if I'm adding a 1 and I don't have a calculator, 1 whole is the same thing as 1 over 1, or 2 over 2, or 3 over 3, or 4 over 4, or 5 over 5. So if you're adding 1 whole to a fraction, just make that 1 whole equivalent to the denominator over the denominator. Whatever your denominator value is, make it that over itself. Okay, so we're going to do 5 over 5. What's 32 plus 5? 37. So we would get 37 over 5. Okay, so there's my final simplified linear expression or linear equation. That's if I use the first point. Again, it's identical even if I use the second point. Let me show you what I mean. If I do y minus 9 is equal to negative 4/5 times x minus negative 2. I have those double negatives. I don't like having double negatives, so I'm going to go ahead and convert that to a positive. So that becomes y minus 9 is equal to negative 4/5 times x plus 2. I would then go ahead and distribute. That becomes negative 4/5 x minus 8 over 5. So we wind up having y minus 9 is equal to negative 4/5 x minus 8 plus 5, or 8 over 5. And then we would add 9 to both sides. By adding 9 to both sides, if I needed to have it in equivalent fraction form or a common denominator, the common denominator is going to be 5. So 9 is the same thing as 45 over 5, right? 45 over 5 is going to equal 9. So 45 plus a negative 8 comes out to a positive 37. So you get negative 4/5 x plus 37 over 5. It comes out exactly the same no matter which point you pick. It does not matter. So if you're given 2 points, you have to find the slope by using slope formula first, the subtraction of your y's over the subtraction of your x's, and simplify. Then you just choose one of the points and plug it in for the point slope form. Go ahead and do example 5 on your own. All right, let's take a look. First thing that we had to do is find the slope. So you're going to take the difference of the y's over the difference of the x's. If I did negative 8 minus negative 12 and then negative 2 minus the negative 5, that's going to give me a positive 4 over positive 3. If you did negative 12 minus negative 8, that would have given you negative 4, and then negative 5 minus negative 2 would have given you negative 3, but a negative over negative would give you a positive. So either way, you should have come out with a slope of 4 over 3. Then you just pick any point. I went ahead and picked the first point to plug it in. So I did y minus my negative 8 is equal to 4/3 times x minus my negative 2. I have double negatives for both the y and the x over here, so I'm going to simplify them to y plus 8 and x plus 2. Then I distribute. 4/3 times x gives me 4/3 x. 4/3 times 2 gives me a positive 8 over 3. I would then have to subtract 8 from both sides. By subtracting an 8, it's the same thing as saying minus 24 over 3. Minus 24 over 3 is the same thing as minus 8, but then you have a common denominator. So 8 minus the 24 would give you a negative 16. So you get negative 16/3. So y equals 4/3 x minus 16/3. Any questions? Okay, we have a couple of special ones off to the side, some special lines. And I'll put this back up here in a moment. But let's take a look at some special equations. Special equations meaning that they have those very special types of slopes. So the undefined slopes and the zero slopes. Whenever you have an issue or an example where it's an undefined slope and a given point, it's very, very simple. With an undefined slope, what are undefined slopes looking like? What kind of graph does an undefined slope look like, Eric? A line that just goes straight up and down, right? We call that a vertical line. So for an undefined slope, it's just a vertical line. Okay, so that vertical line has all these different values for y, but it only has a single value for x. X will always be the same. So anytime that you have lines that are undefined slopes, your equation is always going to be x equals and whatever your x coordinate is. Your equation will always be x equals and whatever the x coordinate is. So for example, 1, our x coordinate is a 5, so our equation is going to be x is equal to 5. For number 2, our x coordinate is negative 6, so our equation is going to be x is equal to negative 6. For number 3, our x coordinate is a 4, so that means our equation is x is equal to 4. And then for problem 4, our x coordinate is negative 5. So x is going to be equal to negative 5. This is for undefined slopes. So let me go ahead and underline that or highlight undefined slope. If you have an undefined slope, your equation is always going to be x equals and whatever the x coordinate is. What do you think it's going to be for zero slope? The y. Because with a zero slope is just a horizontal line. So that means you have an infinite amount of possibilities for your x, but you only have a single value that it always crosses at for the y. Only a single position for the y. So your equation is always going to be a y equals and whatever your y coordinate is. Y equals and whatever the y coordinate is. So in this case, we're going to have y is equal to 9. What about for number 2? 7. Y is equal to 7. Number 3. Negative 3. Y is equal to negative 3. Number 4. Negative 1. Y is equal to negative 1. So those are for those special ones. If you have an undefined slope or a zero slope, you have a special type of equation where it's just x equals a number or y equals a number. Go ahead and grab your computers